Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and today is the perfect day for hashing things. So we're going to do design hash map. That's our next problem. Okay, so we need to design hash map, and if you haven't done the hash set problem, which is right here, we just solved it a day ago. Now the reason I'm asking you to refer that, because these both problems have the same fundamentals. So hash set only stores just the keys or the values, unique keys, and hash map just have a key and value, which could be different, which could be same. So let's implement this. So we are going to implement the myHashMap class, which has these three main functions. Then the constructor will hold the data structure that we will be using to store. So these are the three functions, core three functions that we will be implementing. So let's go over how we can do it. Here, these key and value could be in the range 10 to the power 6, and at a time unique key value size, or number or size, would be 10 to the power 4. All right, this is written in the constraint, so you can refer from there. They could change it next time, right? So what is the brute force way of implementing this hash map? Now what is the very common data structure that we know? That is a list in Python that we can use, and list stores any value as using the indexes. So here they have given us, like, the values are going to be integers, keys are going to be integer, and values could be anything, but in this case they're also integers. So let's talk about the brute force solution. Here, what is the data structure that we know? Simplest data structure that can store some values, and keys could be the indexes. It's list, right? So we can utilize in this particular problem. We are given keys and values as integer, but in general scenario, like in a hash map, it's not just integer that you store anything and everything. Even you can store a hash map into a hash map. So crazy, right? So in this particular case, for keys and values, what if as my key I can just use the indexes of the list? So let's say if they're asking us to create the map, so I would create this list, and this list will be the size of the hash map they're asking us. Initially it could be just 10 to the power 4, but when they are asking us to put the keys, I can just for this key being the index, so these indexes 0, 1, 2, I could use this as key, and then this value can go right here. So if, let's say, I was given put 0 and 5, so this key right here, this index 0 would be the index, and then I can put 5 right here. Same way I can put more values here, let's say 6. Then to get the values, they will give us key means index, and then we can access using that key as an index and get this value. Let's say at 2 we stored 8, so we can get this. And also same goes for removing. For that particular key, you can go, let's say if they're asking us remove, let's say key is given 2, then I can go here and change this value to -1 or whatever. Like initially you want to store, you can store it as 0. You could leave it empty, but when you're creating a list, initially it stores by default 0 value, or it at least asks you what's the default value you want to give, or you can even have none. Yeah. Alright, so that would be the brute force solution, and it will work in this particular case. You can write this and submit. It should get accepted, right? But what if there are collisions? Then this will not work. What if you're trying to store 2 different keys at the same index? Then it will not work. So what do we do about that? what do we do about that? So in that case, we will still have list. But instead of treating these indexes, so 0, 1, 2, 10 to the power 4 whatsoever, instead of storing the value here, I will store from all these indexes. I will point a next pointer to a list node. So I will create a list node. I can create a dummy node right here. So this will be a dummy node. This will be a dummy node with 0 value. I will create list node, which will create, this class. List node class will have a key and a value and a next pointer. Okay, next pointer. So these are the attributes of list node: key, value, and next pointer. So key value, this key right here would still be from the index. We will refer, but here when you access that, you are not just accessing, at this value, you are accessing a list node. Initially they all have 0 key, 0 as a key or value, whatever, but next time you can store, this is the key right here, 0, and there could be 0 value as well. But then next time you want to store something, let's say you want to put key is 1 and value is, let's say, 5. This is key, this is value. So I will basically, from this list, I will go to the one index because that's my key, and then I will access this current pointer. So these are my current pointers. So these are all current pointers. So now if I have this current pointer and I see that it's pointing to none right now, right? Its next pointer is not pointing to anything. So what I'll do is I will actually place this list node, next list node, this right here. So the key will be 1 and then value would be 5. So that's how I will store it, and then I will place its next pointer to none. So that let's say if next time there is another key. So the reason we are doing it, so we can handle the collision. Let's say the size of my list that I'm creating is from 0 to 10 to the power 4. Then let's say 10,000, you can say. So for key 1 and 5, I will be storing it right here. But what about if my keys, so this is 10,000, 10,001. 10,001 will also go over here, right? Because you will be modding it with 10 to the power 4. That will give you again 1 as a key. So you will also again be storing that here. So if I give the key 10 to 1 and then let's say 8, then I will access this and then I will go to its end. I will remove this and then I will store its next pointer as 10, 10, 10, 1 and 8, key and value, just like that, because they're sharing the same keys. These keys, remember, these keys are the reference keys. Now indexes are the reference keys. They're referring to a data structure, which is this linked list right here. Okay, this is a data structure. They're referring, these are reference points. Now these are not the keys for accessing the value, because the value right here is just a reference to the some dummy head node of our linked list. So these are all linked list. So let's implement it. I think things will become really clear. And even in this particular case, the time and space complexity, would not change from the brute force solution, unless there are like a lot of collisions you see, and then at max, some unique keys make a big number, after the collision, and then after the collision, some duplicate keys make a big number that could be k. Okay, so let's create the list node class, list node, and here I will create the constructor. This will take self, and you can give this key and value. So self dot key equals to key self dot value, and this value could be none. If you are not giving it anything, we can just have it, you know, declared none or 0. Now this value would be value, and next pointer to refer to the next. This time it's none because currently this node you currently create, it doesn't point to anything, you know, right now. It's an independent linked list or list node in itself. So here let's create our, you know, hash map. So I'll call it hash map, and it will be a list of list node, and we can give it initially key as 0 for in range 10 to the power 4. That is the distinct number of at max number of values that will be keys and values, you know, those pairs will be stored. Now let's put something here. So in order to put something, first I want to get the reference to that dummy node we created, right, for that particular index. So I will get it from self.hashmap. So this right here, but here I will be getting it based on the key, and that key here could go you know, more than 10,000. So that is why I will mod it with the length of hashmap right here. But since we know the length is 10 to the power 4, I can just put 10 to the power 4, or a better way would be length of self dot this hashmap. So I'll just put this value right here, or you can just put this thing right here, although better practice is this. Now I have the reference to the current pointer. What do I want to do? There might be already some keys and values stored next to that dummy pointer. So what I'll do is I'll keep going while cur.next there is some value. Current is dummy, but if there are values stored there, then I would check current.next, and if this cur.next.key is equals to key, then that means there is already a key that exists. So you just want to update the key with the value. So this cur.next.value val equals to the value that's just given to me right here. Awesome. And then I will just return I've updated the value. I don't want to do anything. Otherwise, keep moving this cur pointer to cur.next, and once you don't find anything to the cur.next, then you will put cur.next as list node with the key and the value. Right? That's it. Now, after writing this put, everything becomes really simple for us. How? Let's try to get the value based on the key. So here I will just copy this part, and this current pointer I will try again access it using that key after modding it with the length of the hash map. Then to get the value, I'm trying to get to that key. Once I get that key, then I will instead I will just return the value. So return cur dot next dot value. Awesome. Otherwise you keep moving forward, and let's say if this didn't exist, we were asked to return -1, right? If this didn't exist, then we were asked to return -1. Now same goes for removing. Same goes for removing. We will just have the same functionality right here. You know, in order to remove, first you'll get to that particular key. Now you are here, and now you're here. Then you can just simply, so this current dot next pointer you can skip. So cur dot next dot next, and then return. And I don't think they have asked us to do anything. Removes the key and its corresponding value if the map contains the mapping for the key. If it contains, that's what we return. And they haven't asked us to remove to return anything, so we will just do nothing here. Instead, it fails later. So I'll just zoom out, and I think we have done everything that they have asked, right? So let's try to run it. Let's try to run it. So when we are removing, we are just removing the reference of that. All right. So I will just, we are skipping. You know how you delete some node inside a linked list. So this works. This works. You can have a look again at the code. Right. Awesome. So let's submit. Great. So we already talked about the time and space complexity, right? For time complexity, it should be of big of 1 in ideal scenarios if the chaining is in, or you can say k, where k is the, you can say values, number of values that belong to same key, right? Because you'll have to iterate through all of them to either remove or get or put, right? For space complexity, we can say let's say if size of the entire hash map is n, then n into we can say k, right? K is the maximum of those keys that are in the same key value. Yeah. All right. So this is done. Let's mark this complete. I think I'm thinking of adding like a button here that will give you the code. So you click on it and it should give you the code that we have written over there. So I will add that functionality today. Well, see you guys later in the next problem.